Hopefully everybody has found today's lesson okay. Once you finish this review of similarity, then you're going to take the quiz found right beneath this in the content, the 3.10a quiz. We're going to do a little review on similarity. I'm going to mix up the problems a little bit so we get used to pulling which of the proportions we're going to pull off of our notes and use. The basic fundamental of all this unit is that when I have similar shapes, the sides are in proportion. And what that means, it means I have equal ratios. So when I'm looking at something like EH, and it corresponds to JM. When I say it corresponds, I mean, you see here how angle E is marked with 2 arcs, and angle H is marked with 3 arcs? That means those angles are the same. And the side in between them would be corresponding sides. E and J would be a corresponding angle, H and M would be corresponding, and these sides are corresponding. Notice that the angles are the same size, but see right here it says angles are congruent, corresponding angles, but the sides are not. They're not congruent, but their ratios are, meaning they're in proportion. So when I take the length of the side, obviously you can tell they're not the same length, but the length between their sides, 3.16 to 6.32, will equal the same ratio if I get 2 other corresponding parts, like 1.2 and 2.4. If I change these to a decimal value, okay, if I take 3.16 and divide it by 6.32, I'll see that that is equal to 0.5. And so is the second ratio, 1.2 divided by 2.4 is 0.5. So one way that we came up with to see if these were in proportion was changing the ratios to decimals and seeing if all the ratios matched. Then we started looking into finding missing pieces, and that's where we set up proportions and solved. So the first problem I want you to practice today is finding the missing angle. So take a look at this problem, pause the recording, see what you get for the measurement of angle D down here, and then go ahead and play the recording and I'll show you the answer. Okay, hopefully you were able to set this problem up. I always start by writing down the angles that I have, and you can see that B is 58 and F is 80. That was given to you. And we're trying to find angle D. So I know I need 2 out of 3 angles here in the triangle in order to find the third angle. So let's look at angle E, and I really need that angle. And notice that it's the second letter in the name for the triangle, and it matches with B. And remember, we just said the corresponding angles are congruent, so now I know that this angle E is 58 degrees. Now I have 2 out of 3 angles, and I can take the 180 degrees that I have to spend around on my 3 angles there, kind of like a budget of degrees, subtract out what I've used, and I get 42 degrees. Okay, since these 2 angles already used up 132 degrees, I know I had 42 degrees left for this angle right here. And I also know that angle A would be the same. Okay, so that was one way we could use the corresponding angles. Make sure you realize the corresponding angles are congruent. The sides are not. Okay, moving on from there with similarity, we started setting up those proportions we talked about. And you can see here I have different proportions that I set up in the beginning of this unit. First of all, I started setting up corresponding parts or sides of the triangle. So we started getting into looking at a lot of these ratios in triangles. So we had the corresponding sides. Then we did the side splitting theorem, where I found out that these pieces, I set it up as A over B equals C over D. These pieces that are cut by the parallel line to the bottom are in proportion. And the same, very similar thing happened when I had 3 parallel lines and started drawing in transversals. They too were broken into proportion. Okay, so this is just kind of a screen that kind of shows you all the different ratios I could set up with similar triangles. Now here's the one we just talked about. The sides are in proportion. And notice I'm using consistently in each of these sets of pictures, I'm using the ratio A over B equals C over D. So let's start with the one we just talked about down here with these orange triangles. Those are similar triangles. The corresponding parts are in proportion. So that's how I could set that up. Then we looked at other parts of the triangle. I could set up the medians. Okay, see how this right here, this piece down the middle of this triangle, that's a median. Well, those were in the same proportion as the sides also. So I could use them kind of like I used the side. Same thing held true for the altitudes right here. As long as they're both altitudes, they'll be in the same ratio as the sides, A over B, C over D. And then it also worked, that same ratio setup worked for the angle bisectors. So I'm setting up these corresponding parts, not just sides, but also altitudes correspond, medians, and angle bisectors. So lots of different ratios I could set up there. And then we have the side splitting theorem, and these, they're very closely related to the point that this was a corollary or kind of a sub-rule to the triangle here. We found out that if I drew these lines parallel, and that's really important that the lines are parallel, that the transversals would be broken into pieces and they'd be in ratios that would be equal. Just like if I do it in a triangle, the two sides would be broken into ratio A over B equals C over D. The last ratio that we did was for if I had an angle bisector, it would break the opposite side into the same ratio as the two sides that formed that angle being bisected. This was the last picture that we had. So we're going to use these pictures to kind of guide us through these next problems. We had to figure out which picture we're referring to. Okay, so I have two different triangles here, and it looks like I have arcs in these angles showing that this line is going down the middle. So let's go back to our notes, and it matches up with this picture down here. See how I have similar triangles, and the sides A over B equals C over D. So they're in proportion to corresponding sides. So that matches up with that rule right there. Go ahead and pause the recording now. Go ahead and solve this one. You're finding segment LM right here. I'll put an X there. And then when you have it, go ahead and play and watch the answer. Okay, hopefully you didn't have a problem setting this one up. Corresponding sides, I'm going to do X over 8. Now I usually start with my sides, and I'm not sure why, but you guys can kind of develop your own. And let's highlight what goes together. Those are corresponding sides. Now, the other pieces that I have in here are angle bisectors. As long as they're both angle bisectors, they'll be in the same ratio. So I'm going to set those up. Now I went X on top, so I'm going to start with the 14 on top, staying consistent, and that 14 goes with the 6. All right, now we're ready to cross multiply and solve for X. So this part always seems to follow the same pattern. 8 times 14 equal to 6X. And then I'm going to divide both sides by 6. Now I always get X alone, and then I put it into my calculator all at once. Just something that I find easier to do so that I just have to open up my calculator one time. And I can do all of my keystrokes all at once. 8 times 14, then divide by 6. And I get 18.6 repeating. So hopefully that was your answer on this one. Okay, so these set up just like we set up corresponding sides. Okay, go ahead and read through this problem. I have AB, AE, and EC. You're trying to find AD. Go ahead and set up the problem, and then turn on the recording and watch the solution. Okay, let's go ahead and take a look at this one. Now, first of all, I like to highlight what I have, okay, just so that it helps me pick out the rule that I'm going to use. There's AB, and I also know AE over here is 6, and that's a part. AB was the whole thing. EC was 8, and I want to find this piece up here, AD. So I'll put X next to that. Okay, so I'm trying to find a part, and the other piece that I have here is the whole thing. So I'm going to use some of my properties here to help me set this up as easy as possible. I always look on the side with what I'm looking for. I'm looking for the X. And what I have is the whole length. So if I'm going to set up a ratio that uses the top part over the whole side, I have to stay consistent. This is the side splitting theorem, but remember, we also use that property where we found out we don't have to just set up part over part, we can set up part over whole as well. Okay, so if I'm going to compare the X to the 16 over here, I'm going to compare the 6 to the, oh wait, I don't have the whole thing, I better find that. 8 plus 6 is 14. So I'm going to have to add the 8 and the 6 together so that I have an amount over here that relates to the 16. Okay, if I'm going to do part over whole, I have to do part over whole here. Also, notice that I chose the 6 because the part that I'm looking for is up here, and I want to use the part over here from the same area of the triangle, or part of the triangle. All right, so now we have this set up. I have 14x equals 6 times 16. Now everything's kind of following that pattern, dividing both sides by 14. Like I said, I like to set the whole thing up before I go ahead and solve it. So 6 times 16, I'm going to divide by the 14. This time I got 6.857. I'm going to round that to 6.36. All right, let's go ahead and move on to the next problem now. Okay, on this particular problem, it is, we're looking for IH, and we have the 3 parts here. Okay, we have all parts here. So going back to our notes real quick, just so that you see how we reference those notes to help us. I go back to my notes. Now I like this set of notes where I'm looking at this, and I'm trying to find where do I have a picture that looks like the problem that I'm doing. And hopefully you can see, as you look through your notes, you can find the picture that matches the problem that you're doing. I have parallel lines, I have transversals. This one's pretty easy to pick out. In this case, I have all the parts. Now remember, if you have the whole, you can also do parts over wholes, but I don't need to do that one this time. Okay, so this one's pretty straightforward. Go ahead and hit pause, solve. This one is a multiple choice, so you can choose your answer, and then go ahead and hit play when you're ready to see this one solved. Okay, this one almost sets itself up. Okay, when I have all the parts here, I call this one X. The X over the 14 is the 9 over the 16. Hopefully you can see the ratio kind of setting itself up right in the problem. So I have 16X equal to 9 times 14. Dividing both sides by the 16, I will get X alone. So now I'm ready to put that into my calculator. Is it starting to look like what you did? 9 times 14. And hopefully you got B for your answer, 7.875. Notice the difference between this one and the one we just did. This one, since I was looking for a part and I had a part, that's what I wanted to use on the other side. I didn't have to find the whole length, so I wasn't using that. Okay, hopefully you see the relationship here with finding these similar triangles. And you see that as we set these up, I can set up any of the sides, the medians, altitudes, or the angle bisectors into proportions. As long as you're careful to make sure that if I put in on this triangle, I see that I have an angle bisector, it would be in proportion to an angle bisector in its similar triangle over here. Okay? So I'm going to do one really easy just to demonstrate. If this is 10 and this is 5, this is 8, then this would be 4. Okay? The angle bisectors will be in the same proportion as the sides. Now, I can change this picture up really quickly, and these problems all look exactly the same. Let's say instead of having an angle bisector, I have a median. So I'm going to move it just a little bit. Now, the angle bisector and the median are often very close. And let's say now that I put it in like this, and you can see that it meets at the midpoint. Same exact problem though. 10 over 5 equals 8 over 4. The problem doesn't really look much different. You just have to recognize that I can use these other parts in my proportions as well. Then last but not least, the problem would look exactly the same if I straighten this up and turn it into an altitude. Those will be in proportion also. So if I give them the same numbers, the problem looks exactly the same. 10 over 5 equals 8 over 4. Okay, so if you understand that it doesn't matter which parts I have as long as I have the same part in both, altitude, median, or angle bisector, I can set these ratios up the same way I set up the corresponding sides. So those are the ratios we have so far. Okay, and if you understand what they are, you should be able to apply them to all of these different situations. Side splitting, pieces inside of the parallel lines. Remember, when you're doing these two, you could also set them up the A over A plus B part to the whole as well. When we had the angle bisector, the side splitting here, and also all the parts of similar triangles, sides, altitudes, medians, and angle bisectors. So what you're going to do now is you're going to move down. Below this in your course, you will see the quiz 3.10 B, or A. We're on A today. This is the first day. 3.10 A quiz. You're going to do 5 of these practice problems. They aren't meant to be hard. They're just going to be a mix from all the different lessons that we've done, so you can't count on that problem being that kind of proportion of the day. We're going to mix them up a little bit. You'll have 5 problems to work on. One of them will be about the angles. The other 4 will be proportions to set up and solve. Nothing fancy. Just want to make sure everyone can do the basic problems that we showed today. And then that will be it for today. If you think after going through this and doing these practice that you'd like to try again some of the quizzes that you saw, go ahead and K-mail me and I will open those up this evening.